Hey everyone, welcome back to my channel. This is Elaine Giselle, and if you're new to the channel, I make videos about education, electronics, and lifestyle, and whatever it is that I can think of that may add value to your life. So in this video series that I'm making, I will be making a tutorial on Proteus simulator. So I already made an Arduino circuit simulator, Arduino circuit simulation in Proteus. In my previous video, you can check it out somewhere here. I'm going to put it here and on the description below. And I'm going to start by introducing how to navigate, explore Proteus simulator, and make a very simple circuit. Second video, I will be making a half-wave rectifier. Lastly, I'm going to make a full-wave rectifier. So if you're interested, continue watching this video. I'm also going to link the playlist somewhere. So let's go. Okay, so this is my Proteus Design Suite 8.9. And if you haven't watched the first video for Proteus Simulator, then just check out somewhere here how to use the Proteus Design Suite. For simple circuit, I also have the Arduino circuit tutorial for that, and you can check them out. All right, so today, in this video, we are going to be making a half-wave rectifier and measuring it using the oscilloscope. All right, so let's click the schematic capture. Again, I'd like to make my life simpler and easier, so I'm just gonna click the schematic capture, and you can save it later. All right, so I already have I already have some devices in here, so I'm just gonna delete it so that we can start from scratch. All right, so again, we're going to be making a half-wave rectifier, and for half-wave rectifier, we need a sinusoidal voltage source, a diode, an ideal diode. We can set ideal or a silicon diode can be used for that, and a resistor. Okay, so let's go and add the devices or add these components. So press P on your keyboard to access the devices, and then search for V sign. This is our sine wave AC voltage source. So we can double click that and it will be added here on our devices. And then we need some diode. Okay, for under the category, click diode, and then for a subcategory, click the generic diode. Right, this one. And then we need some resistor. So click resistor, and then again, click the generic under the subcategory. Okay, so these are the components that we will be needing for our half-wave rectifier. So let's go ahead and make the circuit. So click the V sign. Let's add some here. You can zoom it in using your mouse scroll and adjust. Right, and then the diode should be connected to our V sign, and the resistor should be the output component. Right, so click connect all the components. Right, and then we need to add the ground from the terminals mode, and then click ground. Okay, we already have a half-wave rectifier circuit. This is actually the half-wave rectifier circuit. So we may need to adjust the V sign amplitude if you want. It has a default value, but let's just set it to 12 volts. And then for the diode, this one is a silicon diode, so we cannot adjust the value. So let's just click OK. And then for the resistor, we can change this value to 1K. All right, so let's zoom it out a little bit. In order to see our waveforms, we need to add an oscilloscope, and we can find it under the instruments here. All right, so if you want to see the input and the output waveform, all we have to do is use the two channels in our oscilloscope. One is for the input and the other is for the output. So we're just going to be using channel A and B for input and output. So click A and connect it to here in our output in our input, the V sign. And for our channel B, that is the output. So we can connect it parallel to our R1, because for a half-wave rectifier, again, the voltage output is measured from our resistor. All right, so we are going to be expecting an output waveform that is half-wave, because this is a half-wave rectifier. All right, so before we run the simulation, let's first edit the frequency of our V sign. We can set it to 60K, 60 hertz. Yes, 60 hertz. And click OK. So we can now run the simulation. Let's click run. All right, so when you first run the simulation using oscilloscope, there will be a digital oscilloscope that will come out from like a new window. But since I accidentally closed it a while ago, then we can access that from our debug and then go to digital oscilloscope. Okay, so this is now our output waveform. So we can adjust. Since we're not using the channel C and D, we can just turn this off. All right, so this is now our channel A and B. Now the A is the yellow one and the B is the blue one, which is the output waveform. So we can adjust our waveform. So let's just make sure that it has the same value for the time division, so that we can overlap our waveforms. Okay, but if we want to see more than one cycle of our input and output, all we have to do is turn this now for the horizontal counterclockwise. Yes, because if you turn it clockwise, then you will have a lesser number of cycles. So turn that clockwise, so we can see here that our input here, if you want to overlap that, actually we can see that it is only during positive cycle that your diode conducts now has a half waveform. So that makes the circuit a half-wave rectifier. All right, so that is how we simulate a half-wave rectifier using Proteus simulator. And I hope you learned something from me today, and happy simulating, and I hope to see you on my next tutorial. Bye.